Okay, so now we are actually discussing the continuation of the previous topic, that is binary classification, where we'll be seeing about the weights. Okay, that will be added to the, the actuation layer, to the and then the biases that are added. So in this, we'll be seeing that. Okay, what is an algorithm that is used for the binary classification? So basically, there are the algorithm which we are using here is the logistic regression. So by using logistic regression, okay, consider a given input X, okay, which is an input image, and we want algorithm okay that outputs an y hat, which is nothing but the predicted output, okay, or you can say estimated output of y. So y hat is nothing but equal to probability of, okay, y is 1 for a given input X. Okay, so what is the probability of y being the well being cat? So we had seen that in the previous case. Okay, what is the possibility of the cat is the output? Okay, and 0 is nothing but the non-output, the non-cat output. Okay, so what probability of y being the y is equal to 1, okay, for an input X, where X is nothing but the image of a cat which we had seen in the previous PPT. So this is how X is the image of a cat. Now, here X is nothing but we had seen that as belongs to R, okay, and X, where which is nothing but a dimensional vector. Okay, and the parameters of this logistic regression is where W, which is nothing but belongs to R and X, and B is nothing but belongs to R. Okay, where W is a weight and B is nothing but the error rate, okay, which we are applying. So to generate the output y, okay, um, y hat, okay, is nothing but W transpose X plus B. Okay, so this is nothing but the linear function of input X. Okay, and this will be used in the especially in the linear regression. So how and hence this technique normally is actually not good for prediction, because the y hat here value normally will be ranging um, with around +1 to -1. Okay, so since it is ranging around +1 to -1, okay, so that is the reason why we will be applying the sigmoid function, okay, to this logistic regression. So this will be around, so that will be like W transpose of X plus B will be getting a value between 0 and 1. So between 0 and 1, the we need to get the value, because our output should be either 0 or 1. It cannot be between +1 and -1. Okay. So when we are applying the sigmoid function, So we'll get the the curve like this, where any negative value of z, so this is our z value, any negative value of, okay, is 0, and any positive value will be tending towards 1. Any positive value will be tending towards 1, and any negative value z will be tending towards 0, and any positive value will be tending towards 1. So in that way, okay, we will be sticking to 0, 1. Okay, so that is why output y hat, okay, that is the w transpose x plus b, which we had initially told that the value between +1 and -1, up to get this kind of outcome, that is 0 and 1, we'll be applying a sigmoid function. Okay, we'll be applying a sigmoid function. Okay, when a sigmoid function is added to this, okay, we'll be getting in the range of 0 and 1. Okay, so what is this is actually represented as sigma of z. So this is nothing but 1 by 1 plus e power minus z. Okay, so if the value of z is 0, okay, then it is nothing but y hat is nothing but 1 by 1 plus, okay, 0 is nothing but 1 by 1 plus, you can say a big number, which is nothing but somewhat, you can say, close to 0. And if y hat is 1 by 1 plus, that is if z is equal to 1, so e power minus 1, so we'll be getting value somewhere equivalent to 1. Okay, so this is the sigmoid function. Okay, now in the logistic regression, we also see the cost function. So to calculate the cost function, okay, so let's see the the y hat, which is sigma of w transpose x plus b, okay, where we had seen that sigma of z is equal to 1 by 1 plus e power minus z, because this is nothing but my z. Since this is my z, that is why sigma of z is 1 by 1 plus e power minus z. And for the parameter, given parameter, okay, the set of inputs, that is x of 1, y of 1, okay, comma x of 2, comma y of 2, okay, up till x of m, y of m. So we want y hat of I is equivalent to y of y. That is, the predicted output of y should be equivalent to the actual output of y. So this are nothing but the, for the different training examples, for the different training example, okay, that is the x1 y1 x2 y2 up till xm by m. Okay, so what we want is the predicted output should be equivalent to the the actual output y of I. Okay, so the prediction on what you have. Okay, so prediction on you have is nothing but the y hat of I, which we had seen. So this nothing but y hat of I is nothing but should be equivalent to y of I. So what is y hat of I? So y hat is nothing but equal to sigma of w transpose, okay, x of I plus b. So that is what the predicted output is nothing but the w transpose x plus b, which we had seen. Okay. Now, what is this? This can be also written as sigma of z of I, which can be written as 1 by 1 plus e power minus z of I. Okay. So now here you can see that x of I, y of I, and z of I, okay, all are associated with I example. Okay. So now we need to see that loss function or error function to check how well the algorithm is doing. So we have what we need to do is we need to find out first the loss function. So loss function will give us that how much loss has incurred by using that algorithm. So loss function, or you can say the error function, the formula for that is L of y hat comma y, where y hat is nothing but the true label. Okay, and sorry, y hat is nothing but y is nothing but true label, and y hat is nothing but the function. Okay, we need to measure. Okay, that is how good our output y hat is when the true label is y. Okay, so the formula for Ly hat comma y is 1 by 2 of y hat minus y whole square. Okay, that is nothing but the mean of y hat. 1 by 2 is the mean between y hat and y. So 1 by 2 y hat minus y whole square. Okay, so therefore L y hat comma y hat is nothing but the predicted value, and y is nothing but the actual value, is equivalent to minus of y log y hat plus 1 minus y log 1 minus y hat. Okay, so this is nothing but if y is equal to 1, okay, then L y hat comma y is nothing but equal to y is equal to 1 means this will be minus log y hat, and this 1 minus 1 will be 0. That is why minus log 1. If y is equal to 0, then we'll get it as this will be 0. So 1 minus 0 is 1. So we can say it as Ly hat comma y is nothing but equal to uh, minus, because this minus is there, that is why minus log 1 minus y hat. Okay, so that is what you'll be getting. So for this you can say that your log y value should be large, so that is why y hat value should be large, and for this Okay, the 1 minus log 1 minus y hat value need to be large for this case. Now, if for y is equal to 1, then your y hat should be large. Okay, for y is equal to 0, your y hat should be small. Okay, so this is your loss function. And for cost function, so cost function is calculated by cumulative of the loss function. So that is nothing but j of w comma b, nothing but 1 by m summation of I is equal to 1 to m L of y hat I comma yi. Okay, where you can see that this is nothing but the cost function j. This is nothing but cost function j, which is applied to the w and b, which is nothing but equivalent to minus 1 by m. Okay, summation I is equal to 1 to m yi. Okay, so this is the what is lyi, that is, so we'll write it as minus 1 by m. So when I apply this loss to, so when I elaborate this, I'll get it as summation I is equal to 1 to m yi log y hat I plus 1 minus yi log 1 minus y hat I. Okay, so this is nothing but the loss function which is applied to a single training example, and the cost function which is applied to cost of the parameters, that is w and b, for m training examples. Okay, so I'll rewrite it as j w comma b is nothing but minus 1 by n summation of I is equal to 1 to m yi log y hat I plus 1 minus yi log, okay, 1 minus y hat I. Okay, that is nothing but the loss function which is applied to single training example, and cost function is, that is nothing but cost function is the cost of parameters w and b for m training examples. Okay, now so this is about the loss and cost function. So if there is any doubt, please let me know. Okay, thank you.